So I wanted to take a minute and explain part of the reason we got the equation that we were looking at, where the hydronium ion was reacting with the hydroxide ion to form two waters, and how we were getting that. So here's what I specifically wanted to do. So this up here, this is my little key here. I wanted to show a little particle diagram. So here we go. I have a chloride ion, which is represented by the green. I've got hydrogen represented by red circles, sodium represented by yellow square, and oxygen represented by a bigger blue circle. So I've got a kid coming around, so it's probably going to get noisy. But basically this reaction is the hydrochloric acid reacting with water to form the hydronium ion and the chloride ion. And notice I did not put equilibrium arrows here. The reason why is because this chloride ion is such a weak base compared to that water that this reaction pretty much runs completely. In other words, there are way more products than there are reactants. So therefore, we just showed because there are way more products than reactants, way more, we show that it's just running to completion here. And then we've got this reaction with the sodium hydroxide. So sodium hydroxide, when I dissolve it in water, it separates into the ion. So we've got the hydroxide ion here, and then we've got the sodium ion there. So when I dissolve these guys in water, these are the species that I'm going to be seeing. So basically there's going to be some hydronium ions, like so. Let me do a couple of these. So I'm going to show that there's a couple hydronium ions present in here, swimming around. We'll go a few, actually. And then we'll go the same amount of these guys. So we'll go copy, paste 3 times, boom, boom. Notice how they're separated, though. They're not together because that would conduct electricity. But we also got, let's say there's equal numbers here. Okay, in other words, this is at the point where it's all the hydroniums have been canceled out by the hydroxides. So therefore, she's squirming. Who knows what's going to happen? Uh-oh. Okay, so we got this in solution, okay? So notice the hydroxides equal the number of hydroniums, and same thing with the chlorides. I'm going to pause this for a minute. Okay, so I've changed my screen, so my key is down here. Here is what I'm going to represent the reactants, and here are the products. So now notice the products of this reaction would be water and sodium chloride. So let's just show this reaction here. So basically what I'm going to be showing here is this. Boop, boop. Oh boy, someone's getting a little fussy, and it's causing me to mess up my picture. Okay, so then basically we have this, where we've got water as a product here, like so. And I'm going to pause it for. So we see a water forming here, but maybe a better way to do this is this. I just thought of this. Oh gosh. So let me take these hydronium guys right here. I'm just going to paste it like this. Okay. So like that. And then I'm going to take this guy because sodium chloride. Oh, so sodium chloride is forming. Well, basically what that means is that I've got my sodium ions and my chloride ions like this. Okay, now for ease of this, since I had 3 hydroniums and 3 hydroxides, I'm just going to copy and paste. Ooh, gosh. I'm going to click on these guys here, and I'm going to paste them like that. Okay, and then I'm going to do the same thing with these guys. So, because the reaction would have run twice. Now, I know what you're thinking. Wait a minute, the product are not hydronium, and the products are not the hydronium and the hydroxides, okay? That, you're right, it's not. What's really happening is this. The hydronium is losing a hydrogen here to form a water. And so now let me separate this guy a little bit. So basically, you took a hydronium and hydroxide and you formed two waters. Well, this thing is going to do the same thing. It's going to move over here. This thing is going to move over here. So why do we not see two waters in that reaction? Well, the reason we don't see that in that reaction is because one of the waters was already there. We're not showing in this reaction that the hydrochloric acid is reacting with the water to begin with. Because really, this hydrochloric acid is not just hydrogen ions floating around, it's the hydronium ions, which we're not showing in the reactants. Now, the way that we get rid of this reaction is we remove what's called spectator ions. And so the spectator ions are the ones that are there before and after the reaction. In other words, they underwent no change whatsoever. So what was there before and after the reaction? Well, the sodium and the chloride ions were there before and after. In other words, I could run this with magnesium hydroxide and I could run this with sulfuric acid, and the net reaction would be the same. We are reacting the hydroniums with the hydroxides to form water. And the magnesium ions would be there before and after, and the sulfuric or the sulfate ions would be there before and after. These are called spectator ions, and so we don't need to really think of them in some of the chemical reactions. So the net reaction that we can think of as happening here is, I don't need to write the sodium ions because they are not participating in the chemical reaction. I do not need to write the chloride ions because they are not participating in the chemical reaction. But I do need to write the hydronium, hold on, Bubby, the hydronium ion reacting with the hydroxide ion to form 2H2O. And that is why we get the reaction that we get.